Well, let's test to see whether p equals e to the it equals cosine t plus I sine t actually satisfies our definitions. And we started with that and we got this, but we don't know if we made a mistake along the way or what, because it's a bit weird. So let's take this and substitute it into this equation and see what we get. So dp by dt, well, derivative of cosine t is minus sine t for real t. Derivative of sine t is cosine t, so it looks like we've got minus sine t plus I times cosine t. Is that equal to I times p? So, well, the I times p would be I times cosine t. Oh, we've got an I times cosine t. And an I times I sine t, that gives us minus sine t. So if we factored out the I here, I times cosine t plus I times sine t, that's equal to p. So it works. I squared is minus 1. This actually allows us to say that p does satisfy that differential equation. Very happy with that. It's a bit weird though, because once we define e to the it as cosine t plus I sine t, we have a bunch of strange things that happen. The one that's going to cause us the most problems is this one. E to the 2 pi I, well, that's e to the I times 2 pi. So that must be cosine of 2 pi plus I times sine of 2 pi. Sine of 2 pi is 0. Cosine of 2 pi is 1. So e to the 2 pi I must be 1. But 1 is e to the 0. So there are two values for which e raised to that power gives the same answer. That means that the exponential function is actually many to 1. The inverse is not going to work properly. We're going to have to think about logarithms in a complicated way to make sure that they work. A more fun one is e to the pi I is cosine pi plus I times sine of pi, which gives us minus 1 because cosine of pi is minus 1 and sine of pi is 0. So cosine of pi gives us minus 1. So this gives us what's been called the most beautiful equation in all of mathematics. If we take the minus 1 over onto this side, we get e to the I pi plus 1 equals 0. So this is a relationship between two of the most fundamental real numbers, the base of the natural logarithms, the square root of minus 1, and pi. So these are the most celebrated numbers in mathematics, and they're all related in this very simple way. Sometimes this is called Euler's equation. Euler was extremely impressed with this equation, and of course he was the first one to discover it. As I said, though, this one is going to cause us trouble. Something that's maybe surprising is e to the I times pi over 2 is cosine of pi over 2 plus I times sine of pi over 2. And now cosine is 0. Cosine of pi over 2 is 0. And sine of pi over 2 is 1. So we get e to the I pi over 2 is equal to I. So this looks like we have a self-referential definition. I is equal to e to the I pi over 2. This is just an equality, not a definition, and it's a consequence of this relationship. E to the it is cosine t plus I sine t. So it has to be true, and at least so far it looks to be consistent, and we will see it come up many more times than just this. Thank you.